So we have e to the x, we've got e to the negative x. X is in the exponent position, and to make it worse, we're not going to be able to use a logarithm for a while because the logarithm only helps us when we have just one term to a variable power. Okay, you can't take it, like maybe we can get rid of that too, but you can't distribute a logarithm. That doesn't work to both those. So we have to do some algebra tricks to get x by itself. The first thing to do, let's multiply both sides by 2. Let me zoom in. Oh, okay, that's good enough. And then if I'm trying to get x by itself, I don't want to have negative exponents because this really means 1 over e to the x, right? So let's get rid of the negative exponent by multiplying everything by e to the x. And the reason why that's going to help is because e to the negative x times e to the x, these powers add up to make 0, right? So this is going to be e to the x plus x makes 2x. This is going to be e to the negative x plus times e to the negative to the x. The powers add up to make 1. Sorry, that's e to the 0, which will be 1. I don't want to jump over a step though. This is 8 times e to the x over here. Okay, so this is 1, right? And the other thing to recognize is that this is quadratic. E to the 2x, that's the same thing as e to the x squared, because powers on top of powers would multiply, and that would bring us back to 2x. E to the 0 is just 1. And so this is quadratic in terms of e to the x. This is where we'll want to make a substitution. This is e to the x squared. This is e to the x. This is no e to the x. So we can make a quadratic equation out of it using this substitution. We'll let u be e to the x. We're going to come back to that substitution to help us finish solving. But what that does is it lets us replace this e to the x with u. Lets us replace this e to the x with u. And now we can solve for u. We can subtract that 8u from both sides and set it equal to 0 because that's how we usually solve quadratics. We set them equal to 0. Okay, so subtract that 8u from both sides. And now that we know it's quadratic, we can plug the coefficients into the quadratic formula. This is a 1 for a, this is a negative 8 for b, this is a 1 for c. So it's negative b plus or minus the square root of b squared, so it's going to be 64, minus 4 times a times c, which is 1, all over 2 times a. So if we simplify that, the square root is going to have a 60 on the inside, and then you can just simplify square root of 60 with a calculator and use a decimal approximation, 7.75 roughly. So we solve it once for plus, once for minus. Whoops. So one answer I got is 7.87 roughly. Then we'll do it once for minus. So 8 minus 7.75 divided by 2. That's 0.25. 0.125 for the other answer. Now, this was when we solved a quadratic equation for u, but the question asks us to solve for x. So let's take these numbers and plug them back in for u in here. 7.87 goes in for u, and then 0.125 goes in for u again. So two separate equations. And to get x by itself, it's in a logarithm, and this time a logarithm will help because it's just one term to the x power. So the best logarithm to use would be a natural log to both sides, because a natural log of an exponent base e, those are inverses. It leaves you with just x. Okay, and so natural log 7.87 is a fine answer. It's not super great though, because I guess decimal approximation. So 7.87, if we need the decimal answer, that's 2.06 over here. X equals 2.06. And then over here we'll use a natural log to both sides. And I'm going to, sorry, that's 0.125. I'm going to skip a step here. Natural log of e to the x is just x, like we saw in the last part, right? So that's natural log of 0.125 for our other answer. So negative 2.08 is our other answer.